Hello, my name is Maxwell Zhao, and I am going to be explaining my presentation or my project over the summer of 2025, done with SREU with Professor Chen. Um, and my project this summer was on multimodal protein prediction. Um, this, um, so the problem we had set out to solve was basically since proteins are composed of a series of amino acids, uh, which then fold into a structure and has a purpose and function. Um, Mutations within this amino acid sequence, even if it is just a single amino acid, can greatly change the protein's function, uh, and can greatly change the protein's function, and whether or not uh, the protein would be harmful or helpful in any way. Um, and essentially, because uh, we don't know how it changes, or we can't predict how, we don't know how every single mutation for every single protein changes. We wanted to essentially be able to predict that using uh, a, an AI model. Um, and so the main thing we used for this project was a multi-layer perceptron, which is a series of layers of neurons, kind of like how your brain works. Uh, Basically taking a series of inputs and additional context and learning through it through each layer, um, and then eventually narrowing it down to an output. Um, and using this, we can basically train uh, a model to predict um, the protein mutations, uh, protein mutation effects from past protein mutation data. Uh, the database we used was Protein Gym, which is easily searchable online. Um, we used the DMS essays, which um, specifically we used the amino acid sequence and the DMS scores. The amino acid sequences being our inputs and the DMS scores being our targets. As DMS score is a um, measurement on how different the or how much of an effect the mutation had on the protein. Um, Additionally, we would later use the how the assays were acquired uh, as an additional context, as well as pathogenicity, which one of the graduate students, Rutia, uh, made a CSV file for me to use. Um, and so we began by doing our ESM2 model, just the ESM2 model as a single modality multi-layer perceptron. Um, we had the amino acid sequence as our input, as our singular input. The output was the DMS score, um, and the hyperparameters. We tweaked the hyperparameters to see if we could find the best model, and that was the most accurate. Um, and we see here, looking to the graph, we have our training and validation loss. Essentially, we basically ran this model hundreds of times, um, and uh, each time it would learn a little bit more. And so we would then save the best version of the model um, and use that for our final training or our test on our test data. Um, and this shows that like you, it ended up learning pretty well at a pretty steady rate. Um, and our final Spearman correlation was 0.68, um, which is basically our accuracy. Um, it's a sort of more, it's a relative accuracy. Um, um, But this served as basically kind of like our like baseline single modality, like no additional context added. Um, and then we decided to look at if we could implement more information um, into our model. This being we used ESM2 and ESM-if, so we added on a structure uh, for the wild type or the original protein sequence um, uh, onto the as additional information given to the MLP. We did this by concatenating the embeddings of the ESM-if to the ESM2 uh, embeddings pretty simply. Um, and this was slightly higher in terms of accuracy, but not by much. However, we were scared that adding on this additional information would actually hurt the model, as it would have to learn on more complex data. However, it did not do that, which is promising. And so we moved on to our multitask predictor, which is essentially a series of MLPs strung together to get multiple outputs, um, given um, given more complex context and information. Um, our input was again the ESM2 and ESM-if concatenated embeddings. Uh, However, this time we added the pathogenicity as well as the DMS assay type um, from ProteinGen and from Rugia especially. Uh, um, and this time we would output multiple DMS scores based on the um, based on the assay type. Um, and you can see on the graph, there's our like literal output that I got, um, being for the five different uh, assay types as well as an overall spearman. This one also had a sixth MLP, specifically for predicting pathogenicity, which is um, whether or not the mutation was harmful or not. Um, and this slightly reduced um, overall this slightly reduced accuracy. However, it did not reduce it by a significant amount. Um, and given that it's taking in much, much more information and context, um, and outputting um, and predicting much more information and additional information that's more complex, um, we found this to be perfectly fine as well, not perfectly fine, but we found it to be fine as we were able to basically get all this information for little to no like trade-off, uh, especially the pathogenicity, which would allow us to give more context to um, the give us more context to what kind of mutation it is, which is really big. Um, you can see here, this was our numbers for accuracies, DSM2 embeddings, ESM2 and ESM-if embeddings, and then as well as the multitask predictor, have all generally around the same Spearman correlation, which means that despite adding more information, it neither hurt or helped our um, our accuracy in any significant way. However, it did provide more context and information um, without harming the models, which I think is a pretty good thing. Um, yeah, and that was my project um, over the summer of 2025. Uh, thank you.